Every single animal you are about to see in this video is constantly making one calculation. How do I survive the cold? And the answer is completely different for each of them. Some of them shiver. Some of them stop moving entirely. Some of them do not even realize they are freezing. And one of them, the last one we are going to talk about, does something so extreme that scientists still struggle to explain it. This is not a video about winter trivia. The science of how animals experience cold tells us something profound about the nature of life itself. And by the time we finish, you are going to understand something about your own body that most people never think about. Stay with me, because we are going to go from your couch to the Arctic. And the last stop might be the most extraordinary thing you hear all week. Before we get into the animals, let us spend just 30 seconds on the science, because it will make everything else click. Your body, right now, is running at about 98.6 degrees Fahrenheit. That temperature is not an accident. It is the result of millions of years of evolution designing a machine that burns fuel constantly, every second of your life, just to stay warm. When that temperature drops by just a few degrees, your organs start to fail. The whole system is fragile in a way that we rarely appreciate. Now here is the thing. Cold is not just a temperature. It is a problem. And evolution has come up with wildly different solutions to that problem, depending on which branch of the tree of life you happen to occupy. The nervous systems of all vertebrates, including you, use the same basic biological machinery to detect cold. The sensation exists because it has to. Animals that cannot feel cold cannot protect themselves from it. But what happens after that signal arrives is where things get fascinating and completely different across species. Let us start with the animal most people already share a home with. The dog. You have probably seen a dog shiver, and that shiver is real. It is the same mechanism your body uses. Muscle contractions firing rapidly to generate heat. But here is what most dog owners do not realize. A dog's normal body temperature runs between 101 and 102.5 degrees Fahrenheit, which is hotter than yours. And the moment that temperature drops below 99 degrees, hypothermia begins. The fur helps, but it does not make a dog immune. In fact, wet fur is one of the most dangerous things that can happen to a dog in the cold, because water conducts heat away from the body far faster than dry air. A dog who jumps in a puddle on a 40-degree day can become dangerously cold within minutes. Size also matters enormously here. Small breeds like Chihuahuas and Whippets lose body heat much faster than large dogs because they have more surface area relative to their body mass. Cold air reaches their core temperature quickly. Below 32 degrees Fahrenheit, small breeds, puppies, and senior dogs are at serious risk of frostbite and hypothermia. Below 20 degrees, all dogs are vulnerable, regardless of breed. When a dog is getting dangerously cold, the body does something revealing. It starts pulling blood away from the ears, paws, and tail, and redirecting it toward the vital organs. The extremities get sacrificed to protect the heart and the brain. That is the same strategy your body uses. You and your dog are running almost identical emergency protocols. The difference is that your dog cannot tell you it is happening. It can only tuck its tail, hunch its back, and lift its paws off the frozen ground, hoping you notice. Now, cats seem more self-sufficient than dogs, and in some ways they are. But they are still warm-blooded, still generating their own heat, still vulnerable to the cold in ways that their confident behavior can mask. Cats are drawn to warmth with an intensity that is biological, not just preference. They seek out patches of sunlight, press themselves against warm appliances, and in winter, sleep significantly longer than in summer. That extra sleep is not laziness. It is energy conservation. A cat at rest burns fewer calories, loses less heat, and extends its ability to stay warm without needing additional food. When a cat curls into that famous tight circle with its nose tucked under its tail, it is reducing the surface area exposed to the air. Every curve of that posture is a thermodynamic calculation millions of years in the making. But here is where we need to pause. Because dogs and cats share something that the next animal on our list does not have. They make their own heat. And once you lose that ability, your relationship with cold changes completely. Snakes do not generate body heat at all. Whatever temperature the air around them is, their body follows. And this is not just a quirk. It reshapes every single aspect of how they live. When the temperature drops below 60 degrees Fahrenheit, a snake begins to slow down dramatically. Its digestion slows. Its muscles lose their ability to react quickly. Below 40 degrees, it becomes almost completely immobile. Think about what that means for a predator. A snake that cannot move is a snake that cannot hunt, cannot flee, and cannot defend itself. Cold is not discomfort for a snake. Cold is a countdown to complete physical helplessness. The snake's solution is brumation, which is the reptile equivalent of hibernation, though it is not quite the same thing. A snake in brumation is not fully asleep. It is something more like a deep biological pause. The heart slows. Breathing slows. Digestion stops entirely, which means snakes actually stop eating weeks before they go into brumation, because having food in the stomach during that dormant period would rot rather than digest. They find underground burrows, rock crevices, or the spaces beneath logs, places where the temperature stays above freezing even when the surface is covered in snow. And in some species, hundreds of snakes share a single overwintering den, their bodies pressed together in a way that looks almost social. In the northern United States, this dormancy period can last from October all the way until May. 7 months of near total biological shutdown. The snake does not experience that time, it simply skips it. Now, spiders. And this is where things get genuinely remarkable. A spider has no fur, no fat layer to speak of, and absolutely no ability to generate body heat. It is an ectotherm like the snake, meaning its temperature follows the environment. And yet most spiders do not simply die when winter arrives. They survive it using a solution that sounds like something from a chemistry lab. As temperatures drop in the fall, many spider species begin producing compounds called cryoprotectants inside their body fluid. The most common of these is glycerol, which functions almost exactly like the antifreeze you put in a car engine. It lowers the freezing point of the spider's internal fluids, preventing ice crystals from forming in its cells. Ice crystal formation is catastrophic for living tissue. The crystals expand and puncture cell membranes, destroying them from the inside. The spider's antifreeze chemistry is what stands between it and that fate. Some species go even further. Research published in late 2025 in the Journal of the Federation of European Biochemical Societies found that certain spiders produce specialized antifreeze proteins that physically bind to ice crystals and block their growth at temperatures well below freezing. These proteins are unique to spiders. They evolved independently from similar proteins found in beetles and moths, which tells us that the pressure of surviving extreme cold has forced completely different branches of the animal kingdom to arrive at the same chemical solution through entirely separate evolutionary paths. The spider did not learn this strategy. It was written into its biology by hundreds of millions of years of survival pressure. And the spiders that produce these proteins are not just surviving winter. Some of them remain actively hunting during sub-zero temperatures, operating in conditions that shut down almost every other predator in their environment. Now let us talk about the cockroach. Because you have probably heard that cockroaches can survive anything. A nuclear blast, the apocalypse, whatever comes. And to some extent, that reputation is earned. Cockroaches have been on Earth for over 350 million years. They predate the dinosaurs. But here is what the cockroach reputation gets wrong. They absolutely cannot survive serious cold. Cockroaches are tropical animals. They evolved in warm environments, and their bodies reflect that. They thrive between 70 and 85 degrees Fahrenheit. Below 45 degrees, they begin to struggle. Below 32 degrees, most species are in serious danger. Below 15 degrees Fahrenheit, the majority of cockroach species will die. German cockroaches, the most common household species in the United States, can be killed within 10 hours at temperatures below 23 degrees. Cold does not just slow them down. It kills them by freezing the water inside their cells, exactly the same mechanism that threatens spiders, except cockroaches have no antifreeze chemistry to protect them. The reason cockroaches seem indestructible is not that they can withstand extreme conditions. It is that they are extraordinary at finding the one warm corner in an otherwise frozen world. Your walls, your heating vents, the warm space behind your refrigerator. The cockroach survives winter not by conquering the cold, but by never truly facing it. Penguins, on the other hand, face it directly. And they do something that researchers did not fully understand until relatively recently. Emperor penguins breed in Antarctica in the depths of winter, in conditions that include temperatures of negative 40 degrees Fahrenheit and wind gusts reaching over 120 miles per hour. Wind chill in those conditions would freeze exposed human flesh in seconds. And yet emperor penguins not only survive in this environment, they raise their young in it. Their bodies stay at around 99 degrees Fahrenheit internally, even while the outside world is 50 or 60 degrees below zero. How is that possible? Multiple systems working together. First, their feathers are layered in 4 distinct rows that trap a pocket of still air against the skin, one of the most effective natural insulation systems on Earth. Second, their feet use a countercurrent heat exchange system, where warm blood flowing outward from the core passes right alongside cool blood flowing back from the extremities. And the heat transfers between the two streams before the cold blood can reach the core. Third, their behavior. Penguins huddle in groups of thousands, rotating constantly so that no individual stays on the cold outer edge for too long. The interior of a penguin huddle can reach 98 degrees Fahrenheit, essentially the same temperature as a human body, generated by thousands of birds sharing their heat. But here is the detail that surprised scientists most. Research published in the journal Biology Letters found that the outer surface of a penguin's feathers is actually colder than the surrounding air. Not just the same temperature, colder, meaning the penguin is so well insulated that its outer surface can drop below air temperature through radiative cooling without any of that cold penetrating to the skin. The penguin is simultaneously warmer than any mammal could survive on the inside and colder than the air on the outside. Now we arrive at the Arctic fox, which represents possibly the most refined cold survival biology of any mammal. The Arctic fox does not hibernate. It does not migrate south. It stays in the Arctic year-round and operates through temperatures that would kill almost any other mammal in hours. It begins to shiver only when temperatures drop below negative 94 degrees Fahrenheit. That is not a misprint. -94 degrees. To put that in perspective, the coldest temperature ever recorded in the continental United States was around -60 degrees in Montana. The Arctic fox does not begin to shiver until it is colder than that. Its fur is considered the warmest coat of any animal in the Arctic. It changes from brown to white in winter, providing camouflage while simultaneously offering maximum insulation. The fur even grows on the soles of the fox's feet, a trait found in no other member of the dog family, allowing it to walk on frozen ground and sea ice without losing heat through its paws. Beyond the fur, the Arctic fox adjusts its metabolism seasonally. In winter, its resting metabolic rate drops by about 25% compared to summer, conserving energy during the months when food is scarcest and every calorie matters. Its body also uses a countercurrent circulation system similar to the penguin, keeping blood at a lower temperature in its legs and feet so that the temperature difference between the paw and the frozen ground is smaller, losing less heat through contact. The Arctic fox does not just endure the cold. It is so precisely engineered for it that a warm day can cause it more stress than a frozen one. And then there is the tardigrade. The tardigrade is not impressive to look at. It is a microscopic animal, less than 1 millimeter long, with 8 stubby legs. Under a microscope, it looks like a tiny bear with too many legs. Researchers actually call it the water bear, but do not let the appearance fool you, because the tardigrade may be the most indestructible animal on Earth. When a tardigrade faces extreme cold, it does not slow down or find shelter or produce antifreeze. It does something categorically different. It enters a state called cryptobiosis, which translates roughly to hidden life. In this state, its body expels nearly all of its water, shriveling into a compact shape called a ton. Its metabolism drops to essentially zero. Not slow. Zero. There is no breathing, no cell division, no energy use of any kind. From the outside, it would appear to be dead. Scientists have revived tardigrades from this state after 30 years of storage at -30 degrees Celsius. In laboratory experiments, tardigrades in cryptobiosis have survived temperatures approaching absolute zero, which is -459 degrees Fahrenheit, the theoretical point at which all molecular motion stops. They have survived radiation doses over 1,000 times higher than the level that would kill a human being. They survived exposure to the vacuum of outer space during a European Space Agency mission and came back to reproduce normally afterward. They have survived all 5 mass extinction events in Earth's history. The tardigrade is not cold adapted. It is reality adapted. It simply stops participating in the physical world until conditions improve. So, do animals feel cold? The answer is yes, and also no. And also it depends entirely on what kind of life you happen to be. The dog shivers and seeks warmth because its body is fighting to maintain a temperature it cannot afford to lose. The cat conserves and seeks and manages. The snake hits pause on its entire existence and waits for the earth to warm again. The spider manufactures antifreeze from scratch with molecular precision. The cockroach, despite its legendary reputation, runs from cold the same way it runs from a light switched on in a dark kitchen. The penguin turns the physics of heat transfer into an engineering solution that scientists are still mapping. The Arctic fox was built by evolution into a machine so perfect for the cold that warmth becomes the threat. And the tardigrade simply ceases to be alive in any measurable sense, then wakes up decades later as if nothing happened. What cold actually is, from a biological perspective, is a set of problems. And every animal you just heard about represents a completely different answer to the same question. Some of those answers took hundreds of millions of years to develop. Some of them are so elegant they look like design. All of them are the result of survival pressure so relentless and so ancient that it shaped the chemistry of life at the molecular level. The next time you feel cold and reach for a jacket, remember that you are doing exactly what every warm-blooded animal on Earth does when temperatures drop. You are defending a number, 98.6. And the fact that you can walk into a heated building whenever you want is not something any wild animal in this video has access to. That number costs them everything.